deprecated libraries, and slopsquatting. Every AI-suggested dependency carries two separate risks. First, AI models often recommend outdated packages with known vulnerabilities because they suggest libraries from training data patterns rather than live registry lookups. Second, AI models sometimes hallucinate package names that don't exist, and attackers have pre-registered many of those invented names with malicious code inside. In this section, we'll cover both risks and give you a concrete checklist to verify every package before it enters your codebase. Why does AI suggest outdated packages? There are three main reasons. First, training data bias. Libraries popular years ago are overrepresented in training data compared to modern replacements. Models favor the most common pattern, not the most recent or secure one. Second, no live registry lookup. Models predict package names from patterns learned during training, not by querying NPM or PyPI in real time. Even agentic tools that could verify a package don't always do so automatically. Third, no CVE awareness after the training cutoff. Models cannot know that a vulnerability was published last month or that a package was deprecated. There's also a subtler danger. Some maintainers deprecate packages specifically to signal a security flaw rather than filing a formal CVE. AI suggestions point you toward this known vulnerable code with no visible warning. Let's look at the specific information that AI does not verify when suggesting a package. It doesn't check whether the package is deprecated, which matters because deprecated packages receive no security patches. It doesn't check for CVEs published after its training cutoff, meaning your app could ship with a known exploitable vulnerability. It doesn't check whether a package has been abandoned, which leads to unpatched vulnerabilities accumulating over time. It doesn't verify the current download count, so a package the AI calls popular may actually have almost no real users. And it doesn't check whether a more secure alternative now exists. The key takeaway is that models favor the most common pattern from their training data, not the most recent or most secure option available today. The numbers reveal the scale of this problem. Research by Aqua Security found that 8.2% of the most downloaded NPM packages are officially deprecated. That's nearly 1 in 12 of the most popular packages. Even more striking, NPM users download deprecated packages approximately 2.1 billion times per week. AI tools that recommend these packages contribute to this enormous volume. A SNIKE survey found that over 50% of organizations experienced outages or security incidents due to AI-generated code referencing outdated APIs. These aren't theoretical risks. AI-suggested deprecated packages are actively contributing to billions of insecure downloads every week. Here's how to verify a package before installing it. Run npm info followed by the package name. Look at the version, last modified date, and check for the deprecated field. Run npm audit to scan installed dependencies for known CVEs. For Python, use pip index versions to check available versions and pip audit to scan for vulnerabilities. What warning signs should you look for? The deprecated field being set is an immediate red flag. If the package was last published more than 2 years ago, it likely receives no security maintenance. If weekly downloads are far below what the AI implied, something is off. No GitHub repository or no recent commits is concerning. And check for any open security advisories on the package. Now let's talk about slopsquatting, a supply chain attack that exploits AI hallucination. The term was coined by Seth Larson at the Python Software Foundation. It's like typo squatting, but instead of betting on a developer's typo, the attacker bets on a package name invented by an AI. Here's how it works. Step 1. AI models hallucinate package names at a measurable and consistent rate. Step 2. Many hallucinations are stable, meaning the same fake name appears reliably across different sessions and models. Step 3. Attackers identify those stable names and register them with malicious code before any legitimate developer does. A USENIX Security 2025 study analyzed 576,000 code samples from 16 models and found that approximately 19.7% of package suggestions referenced packages that did not exist. Let's walk through how a slopsquatting attack unfolds. A developer asks their AI, "How do I validate JWTs in Node.js?" The AI suggests installing jb-parse-utils, a package that doesn't actually exist on npm. Here's where it gets dangerous. An attacker has already run the same types of prompts, identified jwt-parse-utils as a stable hallucination, and pre-registered it on npm with a malicious payload. The developer trusts the suggestion and runs npm install. The malicious post-install script executes automatically. SSH keys, environment variables, and API tokens are exfiltrated to the attacker's server. All of this happens before the developer has reviewed a single line of the package's code. Why do stable hallucinations make this attack practical? If every hallucination were random, slopsquatting would be impractical. But 58% of hallucinated names are stable and repeatable, appearing consistently across 10 identical runs of the same prompt. This means the AI produces the same fake package name for the same type of question across different sessions and sometimes across different models. An attacker runs a batch of coding prompts, filters for names that appear reliably, and registers exactly those names. The USENIX researchers withheld their list of over 205,000 hallucinated package names to avoid handing attackers a ready-made target list. The hallucinated names fall into three categories. 51% are pure fabrications like jw-parse-utils. 38% are conflations of two real packages merged into one fake name. And 13% are typo variants. Because most are plausible fabrications, they're extremely hard to catch by visual inspection alone. Not all AI models hallucinate at the same rate. The USENIX study found significant differences between commercial and open source models. Commercial models averaged about 5.2%, GPT-4 Turbo at 3.59%, GPT-4 at 4.05%, and GPT-3.5 Turbo at 5.76%. Open source models were far worse, averaging 21.7%. Code Llama variants ranged from 20 to 28%. Across all 16 models combined, roughly 1 in 5 package suggestions referenced a non-existent package. Commercial models showed 4 times fewer hallucinations than open source alternatives. But even a 3.59% rate is significant when millions of developers ask similar questions daily. If your team uses a self-hosted or less capable model, the risk is substantially higher. Let's look at 2 real-world incidents. The first is the Hugging Face CLI case. The legitimate Hugging Face CLI is installed via pip install Hugging Face_hub with a CLI extra. But multiple AI models consistently hallucinated a shorter name, Hugging Face CLI. A researcher registered this name with a harmless test package. The result, over 30,000 authentic downloads in 3 months. Alibaba even copy-pasted the hallucinated command into one of their public repository README files. The second incident involves React CodeShift, a conflation of JS CodeShift and React CodeMod. This hallucinated name appeared in 47 LLM-generated agent skills in a single commit, with no human ever writing it. It spread to 237 repositories and was receiving daily downloads from AI agents operating autonomously. Both incidents show the same pattern. When AI agents can run installs on their own, there's no human checkpoint to catch a fake package name. Let's compare the vulnerable versus secure approach. On the vulnerable side, a developer simply runs npm install with whatever name the AI suggested, like secure JP validator. If that name doesn't correspond to a legitimate package, you've just installed attacker-controlled code. Malicious post-install scripts run automatically during installation before you've reviewed a single line. Credentials, SSH keys, and source code are exfiltrated immediately. On the secure side, you always verify first. Run npm info on the package name. A not found response means it doesn't exist. Visit the registry page and check for a real GitHub repository with real maintainers. Cross-reference the install command with the library's official documentation. And when in doubt, use a well-known alternative with years of history, like JSON Web Token for JWT handling in Node.js. Here's the package verification checklist to apply to every AI-suggested package, even ones with familiar-sounding names. Check registry existence by searching the exact name on the NPM or PyPI registry websites. Check the publish date. If it was created days ago or hasn't been updated in over 2 years, that's suspicious. Verify the download count matches the AI's claims. Check for a GitHub repository that wasn't created the same week as the package. Read the scripts section of package.json for suspicious post-install entries. Look for deprecation notices via npm info. Check for security advisories, and always compare the AI's install command against the library's own official documentation. If any of these checks raise a red flag, do not install the package. For common tasks, well-established packages with years of history are almost always the right choice. Here are safe defaults to reach for instead of unfamiliar AI suggestions. For JBT handling, use JSON Web Token in Node or PyJBT in Python. For password hashing, bscript or Argon 2. For HTTP requests, Axios or Fetch in Node, Request or HPX in Python. For schema validation, Zod or Joy for Node, Pydantic for Python. For cryptography, use the built-in crypto module in Node and the cryptography library in Python. For environment variables, dotenv or Python dotenv. And for date handling, datefns or dayjs in Node, and the built-in datetime module or arrow in Python. When AI suggests an unfamiliar alternative to any of these, verify it carefully. These established packages have extensive security track records that newer alternatives cannot match. There's a growing risk as AI agents become more capable: autonomous package installation. When an agent has permission to run npm install or pip install without human review, it can install hallucinated and potentially malicious packages with no one ever seeing the command. The React CodeShift incident is a perfect example, spreading to 237 repositories entirely through AI agents with no human in the loop. The fix is straightforward. Package installation should always require explicit human confirmation. The agent proposes the command, the developer verifies the package on the registry before approving. Commit lock files and use npm CI in your continuous integration pipeline to enforce exact versions. And never configure an AI agent to install packages automatically. To summarize, verify every package before installing it. AI-suggested packages may be deprecated with known vulnerabilities, they may be abandoned with no security maintenance, or they may be completely fabricated names registered by attackers with malicious code. Always check the registry, cross-reference official documentation, and prefer well-known packages with proven track records. Never let AI agents install packages without your explicit review and approval. In the next section, we'll cover secret leakage, another critical risk when using AI coding assistants.